Good morning to you, and we want to just touch on what geographic information systems is all about in generic terms. We want to understand it in generic terms, which is that we are not going to go any deeper than we need to. So what is it? Okay, what is GIS? What is GIS? Okay, and there's no easy answer. So GIS, geographic information. Okay, this is how I like to actually this is how I like to talk about GIS. Look at it in terms of the different words that make up, the GIS, the G, the I, the S. Okay, so geographic. When you say geographic, another name for it is geospatial. Another name for geospatial is locational. Are you all right? Okay, so what has this got to do with civil engineering? I think a lot of people, students ask that question a lot. It's got everything to do with it. That the world is moving into a certain era where I would be very comfortable working with a robotic grader than to have an actual grader vehicle with a human being in it. I mean, I'm the only one who's even qualified to make this statement, but I do think that technology is taking us to a place, and where it's taking us to, excuse me, we will have no option than to work with it and accept the status quo, what is trending. Okay, and what is trending now is information system applications and artificial intelligence. Okay, and geospatial information is fundamental for the system. So we'll talk about what a system is. Okay, GIS is like a system. It's the way things are arranged in such a way that you can get information, which is geographical. Are you all right? So I'll disturb you with the word geographical information in the next few minutes or so. I'm going to just bore you with it, but you need to understand what it actually is and what it stands for. Are you okay? All right, so geographic or geospatial information about places on the Earth surface. So you are an engineer on site. Okay, you are at a place. So once you're at a place, the information concerning the place is what we are talking about. Are you okay? Information about places on the Earth surface, like the story we gave during talking about the mine survey. People getting stuck underground. Are you okay? They get stuck at a certain location. Okay, which sounds more like coordinates. Are you okay? Coordinates, your coordinates. But GIS takes it further. Are you okay? Because you can do more with it than just that information. So information about a place could be, the name of the place, what's happening there. Are you okay? The people there, the objects there, all that, we can collect that and then manage that. Knowledge about what is where and then when, and then you can talk about time. So there's this spatial temporal. The spatial temporal is like saying locate my location and time. Are you okay? So you telling me that there's a lake, all right, behind you, your house or whatever it is, wherever you are, wherever there is a lake. It's not important to me than when did you see this? Are you okay? When did you have this knowledge? Are you okay? And knowledge is from information, and information is also derived from data. So we need to understand this. Please, guys, I'm saying this in the very clear, are you okay? The clearest form that I can. So if you don't get it, don't forget, just put up your hand and you can see. So we don't really know what you are talking about. Because everything gets complicated, but it just doesn't all of a sudden become complicated. All right. So what is where and then when? It's like the objects. Are you okay? Where is it? Where is the object? And then when are we finding the object? Where are we finding it? Are you okay? So knowledge about that. Talk about geographic or geospatial information. And that's what we're talking about. Are you okay? All right. So geographic, so geospatial, the two words are synonymous. Excuse me. Now, when we talk about the system, so geographic information system, all right, we know that G is for geospatial or geographic, all right. Information, everyone here has done some introduction to information technology. So you know what data is, that data is different from information, and that information is derived from data, processed data, and information has to make sense, things like that. All right. But what about the S? So the S, we're talking about systems. Okay, the S stands for systems. Can also look at it in terms of science or studies. So, but of course, here we are interested in the systems. Okay, because I have a master's in geographic information science. You understand that? So the system, but of course, I'm very good with the technology because I can use software as well. So systems is a technology. Science is about concepts and theories. Are you okay? And so the concepts and theories, anytime you mention things like electromagnetic spectrum, are you with me? Anytime we talk about things that relate to physics or things like that, you know, talking about the theory behind it. All right. So there are theories that we need to also know. Studies, societal context, the way we look at it. Okay, but our interest is in systems, the technology, and a system plays one important role. A system is made up of different parts that work together. Are you okay? Always put that in your mind. Okay, like a radio system, what does it do? If you have a radio, you don't expect the radio to just start jumping up and down or dance, something like that. You don't expect the radio to be serving food. You don't expect your TV set to be, I don't know, go and hit your rice food on it. No, you don't do that. It's there to produce sound and then some visuals. That's TV. Radio supposed to give you some audio. Are you okay? You need to hear some sound. All right. So the system always works together to achieve that one goal. Are you all right? Here, our objective in this system is to obtain geographic or geospatial information. In other words, we want to get to know what is where and when. I get it. So that is the whole idea. And also, of course, if you want to know the time too, that would be nice. Okay. So when we talk about geographic information, we have so many technologies. I think we even touched on global positioning systems and remote sensing last week. All right. If you didn't put anything in your mind, this will even refresh you. GPS, system of Earth orbiting satellites, which can provide precise location. Are you okay? Last week, we touched on that. Okay, so that is some form of technology, GI technology. All right, GPS. So people always confuse GPS with GIS. They are not the same, but they are related. They are very much related. All right. So you need to differentiate, draw a line between the GPS and the GIS. Remote sensing, the use of satellites or aircraft to capture information about the Earth's surface. I know if I ask you, you won't mind me, so I'm not even going to bother. You're all right. Yeah, but then I always tell every student that there's always a D-Day. It's all right, where you will know whether you've been a good guy, a good boy, or a good girl. All right, where I will have to ask you the questions. So digital ortho images is also a key product. So ortho images are corrected for, are you okay, certain errors. So when you see ortho, an ortho photo, an ortho image, are you okay? A digital version of that can be generated. Are you okay? And then that can be used for planning, generally for designing, for planning, which is what engineers do. So put that in your mind. Okay. The global positioning system is giving you the location, a precise location. All right. And when we go to the previous slide, you will see that geographic, geospatial information is actually locational information. Are you okay? I told you earlier on that the word geographic, you can replace it with geospatial. You can also replace it with just spatial information system. You can also replace it with locational. All right, so you can see how the GPS is now giving us that location. All right, so in a way, then the GPS is actually a part of the GIS. It's very important. When you talk about the components of the GIS, we'll come to appreciate that. All right, so geographic information systems, software systems with capability of inputs, storage, manipulation, analysis, and output or display of geographic information. It's all right. Now we see it like that. There's a lot in there. Are you okay? So we should be able to make an input of what? Of geographic information. We should be able to store what? Store geographic information. Are you okay? We should be able to manipulate and do analysis of what? Of geographic information. In this class, we won't talk about you analyzing anything. We just want you to know that this is what the GIS can do. That's all in this class. That's all. But even in your next class, that's when we'll see some application. That will be in your level 400. If you get it, I hope you do. I pray you do. And you will. Okay, so software systems which can allow you to simply put in geographic information. All right, so GISs are software. Are you okay? Even though they're not, but they are. Are you okay? You need to, when we talk about the components of GIS, which we're not talking about here, you come to realize that GIS goes beyond just a software. Are you okay? Software on its own may not work. So we should be able to output and display. In fact, this is pointing to the computer. When you look at how computers work, you realize that they do allow you to make an input. Computers allow you to put in a pen drive, put in an external hard drive, whatever, are you okay? And then put it into your software. So if you're using AutoCAD or whatever it is that you are using as your software, you have to plug in, are you okay, a device that brings in the data that you collected. All right. And you can't take your computer, your laptop to the field and it can be done, but nobody really carries a laptop and collects data with it. Normally you have some kind of handheld device. Are you okay? So GPS is, remember that a GPS receiver, we're looking at the handheld, we're looking at the airplanes, and like normally it's a chip, all right, that's installed, all right? And so the software should allow, the GIS is a software, you can look at it in terms of a software system. So obviously once you see, I like the fact that he's added, we added the software systems to it. Software systems. But it should allow you or give you the capability to make an input. Are you okay? All right. Storage, and then manipulate the data. Okay. This time, I hope you're serious. Someone put up their hand. Joseph. Yes. Joseph, you put up your hand. Or people just like clicking on buttons. Joseph Ahin, your hand is up. Or you were just testing it. Should I remove you? You are not part of this class. Are you not going to mind me? I'm removing you, Joseph. Joseph. Maybe he's not supposed to be here. I think I should get rid of him. Anybody knows someone called Joseph? Joseph Ahi? Is he part of this class? Does anyone know Joseph Ahi? Or all of you are not even here in this class. Are you here?
Yes, sir, I'm here.
Do you know Joseph Ahi?
Yeah, I don't know.
Don't know him. Okay. All right. I'll do another check. Okay, Ikea knows him. All right. Thanks, Ikea. All right, so there we go. GIS is okay. So in other words, I can install the software. Okay, and then software now begin to allow me to store geographic information. So what is the form of geographic information? Okay, what form does it take? I think we need to appreciate that as well. Now, GPS and remote sensing. So normally the form that it is, let me just talk about the geographic, how it's stored. Normally it has to be in a certain file format. You start with some raw data, which contains your location, which is longitude and latitude, okay? And then you have to now get that. Let me get my whiteboard so that I can explain myself better. But literally, you have X, Y, Z coordinates that you want to give to a software. Are you okay? It can be in a form of comma delimited. Are you okay? What is comma delimited? In Excel, there's a format called CSV. Are you okay? I'm standing practical here. I'm not talking theory. Now I'm getting practical here. So the CSV format can actually be imported into software, into GIS software. And then now it will display the geographic information. How do you want to see your longitude and latitude being displayed? Yeah, I want to have it, or your X and Y. Let's assume you transform those coordinates, coordinate transformation. Yeah, if I'm able to transform my longitude and latitude to X and Y, then I can now bring it into another software, a GIS software system, where I would be able to actually see the locations. Are you okay? Which is what we see anytime we use Google Map. Are you okay? Anytime the Uber driver, accepts your request, and so you looking at your app, he's looking at his app. That map that you people are looking at is the GIS that's doing that. Are you okay? It's allowing us to visualize. Are you okay? It's allowing us to visualize our locational data. Is that okay? All right. So where was I and what am I sharing? Let me recap on that. Okay. Great. So that is GIS for you. So the definition alone tells you what it is. I want you to appreciate. It is very simple. I don't think it's complicated at all. So GPS and GRS, remote sensing, are sources of input data for a GIS. So just put it, you don't have to even ask yourself. I can only explain to you why we say that, but that is one fact that you all have to put in your mind, that GPS will give you a set of coordinates. Is that okay? From our previous class, we learned that. Now, remote sensing will give you an image of the ground, okay, which is actually reflectances of radiation of the ground, of an object, okay, from the satellite. And the satellite is so many, nautical miles away, so many kilometers away, all right? Now that image can be put into the software, all right? Or we can put in the XY locational data into the software as well, okay? All right. So a GIS provides for storing and manipulating GPS and remote sensing data. I think that is the whole idea. Of course, not only that, we can also analyze and then visualize it. Okay. All right. What does it mean? It means that you can take GPS data. You can use Microsoft Word to look at GPS data. You can use Excel to look at GPS. You can use Excel to look at GPS data. So put that in your mind. You can use PowerPoint to look at GPS data. All right. Okay. Now, storing that data, of course. Yes. Excel is just a format, a data format. You can, it's a software. Microsoft Excel does more than just, storing some data. Are you okay? It can do more than that. It can be used for other things. Are you okay? All right. It's not the core functionality of the core functionality of Excel is not to actually store geographic data. That's what I'm saying. But we can actually put XYZ data into our GIS. Is that okay? All right. So there we go. GPS and remote sensing. Of course, there's another technology called photogrammetry, which actually makes use of drones. Not to forget that also can be can bring in some input. But in this course, we just cannot skip in that. We just want to know that we can make inputs, and the input can be an image or it can be just points that we're bringing in. Is that okay? All right. So systems, technology for acquisition and management of spatial information. Of course, this one is not necessary for you to waste your time on. All right. The common ground between information processing and many fields using spatial analysis techniques. That's the definition, okay, of GIS. Someone's definition of GIS, and that sounds quite conceptual. Are you okay? A powerful set of tools for collecting, storing, retrieving, transforming, and displaying spatial data from the real world. So this one is a very good one. Okay, by Burroughs, 1986. Okay, that's a very good one. All right. So we have another one here, but let's look at the second one again. Powerful set of tools for collecting. So collecting data, storing it, retrieving it. Okay. So retrieving data is also part of the GIS system. So if you have a GIS system which you cannot retrieve, now this retrieval of spatial data means that I want to know, okay, where I have a particular thing or object or activity. So I can now begin to retrieve my data again. Again, getting it back. I want to know. You can also display the spatial data. It's very important. The computer screen is there for you to do that. To display the spatial data, you need a screen. All right. And let's look at this one. A computerized database management system for the capture, storage, retrieval, analysis, display of spatial data. So you realize that GIS can be looked at as if it's a database, okay? And this one is by National Committee for Geographic Information Analysis, whatever. That's actually an association for geographic information, something like that in the US. So they have defined, they have their own definition for GIS, computerized database management system for the capture, storage, retrieval, analysis, and display of spatial data. So you can see that that's also sounding like the previous one, but except that the previous definition is looking more like a toolbox hierarchy definition, and the second one is looking more like, in fact, the second one is what I'm calling the first one, the previous one. The powerful set of tools. It's like a toolbox. You can use GIS as a tool. I'm not going to even spend time on explaining, the differences in the definitions, but I want you to understand that GIS can help you to collect data. It can help you to store them, can help you to analyze them. Are you okay? Okay, there's another definition looking at GIS as a decision support system. So a decision support system involving the integration of spatially referenced data in a problem-solving environment. So they are just different ways of, defining GIS. So decision support system, that really means that GIS is seen to be, something, a tool that helps you to decide, something that helps you to decide, a decision support system, a system that helps you to decide. So for managers, I want to decide on where to put the next facility. Okay, GIS can help you to do that. A decision support system that involves the integration of spatially referenced data in a problem-solving environment. That's kind of an interesting one. It's different from the previous definitions, but they all point to the fact that GIS solves a problem. Are you okay? Once you are analyzing data, what are you going to use the analysis for? Are you okay? Once you finish for analysis, the next step, the natural step to take, are you okay? It follows that you do some sort of decision based on the analysis that you've done. Okay. An inelegant definition for GIS, it doesn't matter. Forget about the inelegant and all those things, all right? I have to trim this note, it's adapted. A system of integrated computer-based tools for end-to-end processing, capture, storage, retrieval, analysis, display of data using location on the Earth surface for interrelation in support of course, that's why the word inelegant is being used there. Interrelation support of operations, management, decision making, and science. Are you okay? I mean, at the end of the day, yeah, GIS is that powerful. I think that's why we are even being introduced to it. I call this one introduction to an introduction. Are you okay? A set of integrated tools for spatial analysis. Yeah. So spatial analysis, like when we look at what is happening in Ghana in terms of the crime rates, people are being killed everywhere. If you want to analyze that, the locations and see, okay, someone was killed here, someone was killed there. When were they killed at this location? When was this crime committed? You can almost come out with something. Are you okay? Without you being so emotional about it. It encompasses end-to-end processing of data. And of course, capture, storage, retrieval, analysis, modification, display it. Are you okay? All right. Uses explicit location on Earth surface to relate data. Of course, we need to get to know the location. Are you okay? So knowing, having information, you can have information in which you don't have an idea where to locate that information. Are you okay? So you can describe something very well. There's a company that actually sells merchandise and it's worth $24 billion. And, the company is actually being run in a very tall story building and 4 floors and everything. And, the owner of the company has 25,000 employees. You can say all this, but where are you getting that? That's on the Earth surface. Where can we find this? That is where GIS comes in. All right. It uses explicit location on the Earth surface to relate data. That's what I just talked about. Okay. Aimed at decision support as well as ongoing operations and scientific inquiry. In fact, that is why in engineering surveying, your mind is being brought to it, because what we're doing in engineering surveying is scientific, very scientific. We're calculating, are you okay, where the road should be and things like that. Are you okay? Earthworks and stuff. Where we need to know the location as well. Are you okay? All right. And we could apply GIS to a lot of things that we do on site. Are you okay? On a construction site, you can apply GIS to a lot of things that is being done there. All right. Excuse me. So that is basically it. I hope you're following. If you have a challenge, I would like you to simply ask me a question as we go. So don't wait till it's too late. Yeah. Okay. So, yep. That is GIS for you. Very powerful tool. It's software, but it may not be. All right. Intuitive description, a map with a database behind it. What does that mean? So when we look at, I'll take Uber again. Why am I always referring to Uber? Because Uber seems to have, it's more popular, isn't it? But there's Yango, there's Bolt as well. All right. Okay, so Google Maps is there. There's what do you call this one? There are other systems that are apart from Google Maps. Okay, but they are not popular. Okay. So MapQuest is there. They are all kind of online. Are you okay? Microsoft have their own maps as well. Don't forget that. All right. And so we are being hooked to Microsoft things. Are you okay? Because Microsoft is powerful and they are very, endowed as a company. The maps that we see on these apps, are you okay? It's not just the map, it's what you've seen on the phone. It's not something to just get excited about it because you just got some money and you bought it. But if especially you are being trained as an engineer, you should know that there's something behind it. Okay, there's a database behind it. Okay, but that database is actually called a special database. It's a very special type of database called the special database. Okay. All right. So a virtual representation of the real world in this infrastructure. So it's not real. It's not something. So a lot of people, when you teach them GIS, they get confused. They begin to ask them, so what are you talking about? All right. We are only modeling the world, trying to represent the world. Are you okay? In GIS, you try to represent the world in virtual reality. Let me just put it that way. That's my own definition. Okay. In 10 minutes, there's going to be the disconnection of this whole Zoom thing. This session is going to expire. When it expires, let's connect again and come back. All right, so that we can continue. A virtual representation of the real world in this infrastructure. What does it mean? It means if you're a designer, if you're an engineer, then it means you could actually use GIS to look at your site for reconnaissance, IOK purposes, and for general or running of the project from day to day. Are you okay? If you are the project manager, you're interested. Are you okay? And you want to just know what is happening. That okay? On your computer, you are in a world, and in that world, you can see exactly where the pallets are. Are you okay? The pallets of whatever, pavement blocks, whatever. You can literally see their location. They've all been geotagged. And as the project progresses, you could update it. Are you okay? A virtual representation of the real world and its infrastructure. That's how you're supposed to look at it. Is that all right? So we represent reality. Consistent as built of the real world, natural and man-made. But listen, if it's supposed to be, a consistent as built, that means that with time, you won't have it as built. I get it. As you move on, if your project is progressing and you're using GIS to monitor and to manage it, you will now realize that you have to keep on updating it for it to become, for you to have the as-built of the real world. Are you okay? All right. So natural and man-made means everything. You can keep water bodies, and don't think about projects that are like that, small projects. Yeah. Think about huge projects that are spanning the country, entire West African sub-region kind of way. Think big. Are you okay? Then GIS will become even more relevant to you. Are you okay? Because then you are going into geographical, you have space. GIS like space. All right. The bigger, the better for us. All right. And scale comes in at a point. Okay. But I don't think, but I think every engineer should know what scale is. Once the word map came up at the top, the first bullet point, you should know that scale is in there. Every map has a scale, all right? If you don't know about it, you can ask, I'll tell you, it's all right. So consistent as-built of the real world, natural and man-made, query to support an ongoing operation. I think I've talked about that. It's okay. Ongoing operation is what? That road that you are constructing, that infrastructure, that's spanning large spaces. Are you okay? That you are putting up. Don't just be there and be thinking of some basic equations for calculating the vertical curves and horizontal curves, transition curves. And you are standing in your mind as an engineer, or as a young engineer, whatever, you are just standing on the site, and that is just where your world is. That's where it ends. But the project spans a larger area. So how's your planning going to go? So what we do in Africa is that every project leader then gets himself a car, isn't it? And then just drives around, just wasting fuel, isn't it? Is that not so? Yeah. Instead of you probably sitting behind one system that allows you to manage and make calls and just say, I see that this pallet has been here for too long. It needs to move. I mean, like, what are we doing to ourselves? Anyway, we need to move on. Let me not get emotional. All right. So this consistent as-built of the real world is summarized to support strategic decision-making and policy formulation. So straight away, I can just make a decision, okay, like I just said, and to strategize and go like, wow, looking at the way things are going, the concentration of the project should now move to the eastern side. Are you okay? How do you do that? You have to just drive there. Is that what you do? Is that not what we want to do so that we can buy the cars, isn't it? All right, so engineering doesn't work that way. Analyze it to support scientific inquiry. Then we can look at it and say, okay, now let's look at it. Maybe we could just change things a bit or create scenarios. Are you okay? All right. Now, on the right-hand side, you see layers, okay? So GIS can organize data into layers. I don't know if we ever don't come back to this. We'll have to. All right, you see soils, all right, you see national wetland inventory, you see land use, are you okay? Digital elevation model. Okay, those who just come on and then will switch off their microphones, I'll remove you one of these days and you can't join again. Is that okay? You don't have to say anything. It's time for class. You just join and sit down and listen. All right. Hydrography, so you can store the rivers and the lakes, layer them. The reason GIS does all this because then when data, in fact, not even GIS that does that. In AutoCAD, you can put your data into layers, okay? So the concept of putting data, grouping data into layers is just, it makes sense so that we can think in terms of themes and topics, different topics. Okay, so you can look at one layer at a time and then work with it, combine layers later on, and then see what comes out of that. Roads, railways, airports, if you're working near an airport, you will need that. Pipe, transmission lines, boundaries, underground utilities. Obviously, you can, it's taking me to the mines now, isn't it? Refuges and parks, of course, and reservations. In fact, what this list that you are looking at is an endless list. Put it in your mind as a student. It's an endless list. But anyway, that is what GIS can do. We have 3 minutes. When it ends, we'll rejoin. Is that okay? Okay, so how GIS is different from related systems? Database management systems. So GIS are not like database management systems. Okay, they are not. Typical MIS database contains implicit but not explicit location information. What we are saying is that there are information systems that make use of DBMS, which is actually digital database management system. Are you okay? But they may not have any location related to that. In that case, we are not dealing with a GIS. We are dealing with an MIS. And that makes a huge difference. Are you okay? So city, county, zip code, no geographical coordinates. They're storing this, their data, a set of data that has been kept over the time, over the years. And people were very meticulous about it, and they stared at it every day, and they thought that was it. Are you okay? Until someone came and said that, no, you're keeping data on these patients, and you know which ward they are, and you know what their diseases are, and you know all the problems that they have. But there's one thing you don't know where they live. Is that okay? And then when someone suddenly just say, okay, now let's look at all these patients. What are they suffering from? Then you realize that, oh, look at where they live. They all live in the same area. There must be a problem there. That is how you help your society to become a better place. Is that okay? I mean, what am I even saying? I'm just saying that not every system is actually like, there are systems that are related, but not exactly a GIS. One of them is the MIS, Management Information Systems, which actually has behind it database management systems. What most GIS we will use is what we call a spatial database management system. Is that okay? Now this is a lecture. You take notes, all of you. I hope you're doing that. Automated mapping, primarily two-dimensional display devices, thematic mapping, couplet map, business mapping software. They are unable to relate different geographical layers. Are you okay? So they can have systems that deal with just the mapping aspects. Are you okay? Go to like a lands commission, they could just use some kind of system that could do the mapping. But what if it couldn't really kind of do a relation between the layers, relate them? Okay, so that is what we're talking about up there. That's a limitation, but GIS can go beyond that. We can relate. GIS can do a query and find out that, okay, tell me